Based on the actual procurement orders from international ship owners over the past 2 years, the most favored alternative fuel vessels are methanol fuel ships and LNG ships. So what are the advantages and disadvantages of these two technological routes? First, let's look at energy density. Both methanol and LNG have lower volumetric energy densities than traditional marine fuel oil, which means that to achieve the same range as oil tankers, more methanol or LNG fuel is required. Compared to fuel oil, methanol requires a larger cargo space to provide the same amount of energy. The required tank capacity for LNG is 2.27 times that of marine fuel oil, while the tank capacity needed for LNG is 1.6 times greater. This means that the tank capacity required for LNG is smaller. Now, looking at the storage costs and convenience, methanol is liquid at room temperature and does not require additional energy consumption for storage. Ordinary storage tanks can be modified slightly to store methanol, whereas LNG must be liquefied at minus 162 degrees. In other words, the liquefaction and storage of LNG require additional energy consumption. The storage tanks also need special treatment, which makes the storage costs of LNG relatively high. The property of methanol being liquid at room temperature clearly offers advantages in storage, transportation, and refueling. Now let's look at the carbon reduction and ecological benefits. Compared to marine fuel oil, using LNG can reduce carbon emissions by 10% to 23%. But LNG is still a fossil fuel, and its main component, methane, is itself a greenhouse gas. Even a small amount of methane leakage can cause issues. Concerns about the carbon reduction and impact of LNG. It is not ideal. Green methanol is produced through a filtration and carbon synthesis process, which corresponds to the recycling of carbon dioxide, achieving net zero emissions. Therefore, its carbon reduction and ecological benefits are very significant. Lastly, regarding the economic aspect of this fuel, since the energy densities of different fuels vary, we need to look at the costs of producing the same amount of heat value. Taking LNG as a standard, the lower heating value of LNG is 49.1 megajoules per kilogram, and the price per ton ranges from 500 to 600. The energy value of methanol is relatively low, at 19.9 megajoules per kilogram. This means that to achieve the same energy value as LNG, 2.45 tons of methanol is required. If we calculate based on the price of green methanol at $750 per ton, the price of 1 ton of green methanol equivalent to the energy value of LNG would be around $1,800. Currently, the price is still very high, equivalent to 3 to 4 times the cost of using LNG fuel. Overall, LNG seems more like a transitional method for short-term carbon reduction in the shipping industry. While LNG has lower costs, its carbon reduction effects are also quite limited. The current cost of green methanol is high, but it can significantly reduce carbon emissions, although future cost reduction potential must also be considered. In summary, if ship owners are choosing alternative fuels, they will likely take into account various factors, including the availability of the fuel, the convenience and economy of storage, as well as the trends in international carbon pricing and carbon taxes, etc. Follow Genyi to grasp the development opportunities in green energy together.
Goodbye.